This is section 15.12, chemical shifts in carbon NMR spectroscopy. Just as we looked in a certain range of frequency for proton NMR resonances, we look in a different resonance or a different range of resonances for carbon NMR because carbon is a different atom. And so it resonates in different frequencies than do hydrogen. We use the same reference compound, TMS, and in general, in carbon NMR spectroscopy, we're looking for only functional groups or bonding patterns, and the signals are much more likely to be governed by symmetry. Now, if you look at benzene and you add two methyl groups to it, as shown here, there are three possibilities. 1,2-dimethylbenzene, 1,3-dimethylbenzene, and 1,4-dimethylbenzene. Depending on the substitution, you'll have a different number of patterns. If it's 1,2-dimethylbenzene, there's an axis of symmetry that you can cut through the molecule like this, which means that there will be 1, 2, 3, 4 unique carbon signals that we observe in the carbon NMR. If it's 1,3-dimethylbenzene, there will be 1, 2, 3, 4, 5 unique carbons that we observe in the carbon NMR. And for 1,4-dimethylbenzene, the symmetry is actually higher. You can cut two different reflection planes through the molecule, so there will only be three unique resonances. And using logic like this, it's typical for how to analyze a carbon NMR spectrum. Also, the location of the resonances play a big part. You can see that we still have roughly the same downfield, upfield relationship as we saw in proton NMR. However, as we mentioned, the range is much larger, up to 220 ppm. So between 150 and 220 generally are like carbonyl-carbon groups, some things that are highly de-shielded. Between 150 and 100, you have sp2 hybridized carbons, like in benzene rings and other pi-bonded systems, well, carbon-carbon pi bonds. And then between 150, you have the sp hybridized carbons and sp3 hybridized carbons with very de-shielding atoms. Between 50 and 0, typically are just your alkanes with no big de-shielding atoms. So whenever you are reading carbon-13 NMRs, please keep these things in mind because the analysis of these spectra are generally easier than for proton spectra. And this was section 15.12.